Welcome to Chapter 1 of Online Statistics. Statistics is all about using polls, studies, surveys, and other data collecting tools to collect information or data from a small part, sample, of a larger group or the population. The goal of statistics then is to learn about the larger group, the population, by examining the data we collect from the smaller group, or the sample, of some of its members. So in the first section, we're going to review some ideas and we're going to get a preview. Some of the definitions we need to talk about are data. Data is just a collection of information, either observations or measurements or categories or survey responses, just information. Statistics is the science of planning the studies, obtaining the data, organizing, summarizing, presenting, analyzing, interpreting, and drawing conclusions based on the data. The population then is the big group. That's the complete collection of all the measurements that we're interested in. A census is collecting data from every member of that population, and the sample then is the sub-collection or the smaller group from that population that we'll collect information from. Okay, next section, statistical and critical thinking. We're going to conduct statistical studies by preparation, then analyzing, then concluding. When we prepare, we ask questions about what do the data mean, what's the goal of the study, where does the data come from, how do we collect the data. Then we analyze the data. We start with graphically, then we apply statistical methods that we'll learn in later chapters, and a lot of the analysis is done with computers, and it doesn't require us to do a whole lot of math. We just have to interpret the results that come off the computers. And then we draw conclusions based on those results, and we decide if something's statistically significant, and then ultimately, is it practically significant? Statistically significant means the numbers work out. Practical significance may mean, so what, does it really matter to what I'm doing? Okay, some common misconclusions or misleading conclusions. The most common one has to do with that one thing causes another. If two things are related, does not necessarily mean that one causes the other. So causation is a difficult concept to discuss. It's very difficult to prove that one thing actually causes another. Small samples, loaded questions, asking questions in different orders, non-responses, missing data, precise numbers, percentages are all areas of misconceptions. So in the third section, we have types of data. The key idea here is to understand what categories data can fit into. Of course, we talked about the larger group being the population, and so a number representative of the population is called a parameter, and a number representative of the smaller group, the sample, is a statistic. So parameters represent populations, statistics represent samples. So data can be numerical data or not numerical data. We call numerical data quantitative, and we call non-numerical data qualitative or categorical data. When we're working with numerical data or quantitative, we can separate it into discrete and continuous, where discrete data is countable and usually in integer numbers, and continuous numerical data can be integers, it can be fractions, it can be decimals, that covers all the values without any gaps. Another way we can separate data is by the level of measurement. We have nominal levels where we can only give names to the answers. We have ordinal levels where the category names mean mean an implied order. For example, good, better, best, or A, B, C, D, F for grades. Then we have interval measures, which are numbers that don't have a natural zero starting point. For instance, years don't have a natural zero, because even the year zero wasn't the actual beginning of time. Temperature doesn't have an actual zero, because 0 degrees Fahrenheit is not the beginning of temperature. Then the highest level of numerical data is ratio, and that's where the data does have a natural zero starting point. For instance, the weight of a person, or the cost of a house, or anything that has a zero that's meaningful. So the levels again: nominal, ordinal, interval, and ratio. Nominal and ordinal deal with categories. Interval and ratio deal with numbers. In the fourth section, we'll talk about collecting sample data. All right, the method used to collect data is important. Basic idea is that we can collect data from two distinct sources: observational studies, where we sit back and look, or experimental studies, where we have our hands in the mix. So an observational study, we don't modify, we just observe. An experimental study, we apply treatments and then observe the effect of those treatments. Simple random sample is the best way to select subjects, and it's literally name in a hat, draw a name. Everybody has the same chance of being picked, and every group of people has the same chance of being picked. Random sample is a little bit less ideal. Each member has an equal chance, but each group does not have an equal chance. Systematic sampling involves picking every kth element in the population. In this picture here, every third man was chosen for the sample. Convenience sampling means you just ask whoever's around. Stratified sampling, you take the population, you divide it into two groups, and you pick some from each group. Cluster sampling, you take your area, you divide it into groups, but then you randomly pick which groups you're going to interview, and you interview everybody in those groups. Multi-stage sampling involves several different types in different phases. We're going to talk about types of studies. Cross-sectional studies, we examine what's going on at a specific point in time. Retrospective studies are studies where we look back on the past, and prospective studies are studies where we plan to collect data in the future. Randomization is important when we design experiments. We don't want all the good-looking people in one group and all the ugly people in another group. We want to randomize which group they go to. Replication is important. We want enough people in each group to know that success was not just a one-time, one in a million shot, that we want it to be able to be replicated over and over and over. Blinding is important in experiments so that the people conducting the experiment don't know what to expect. People taking the drugs in an experiment don't know what to expect. Double blind is when neither the physician administering the drugs nor the patient receiving the drugs has any idea whether they're getting the true drug or the placebo. Confounding is when we have problem distinguishing between the effects of factors, and we try to make sure that confounding does not occur. Some of the other effects of variables that we need to make sure is that we assign the subjects to different treatment groups by random selection, that we separate blocks of people so that we don't have all the same kind of people in each group. A matched pairs design would have two people that are very similar in a lot of areas, one assigned to each group. And a rigorously controlled design is where we carefully assign subjects to groups so that those given each treatment are very similar, at least in the ways important to that experiment. In the design of experiments, then, randomization, replication, and controlling the effects of variables are important. We're going to have error no matter how good we are. There's going to be error because there's just a difference between our sample and the whole population. The only way to avoid error would be to sample everybody in the population, perform a census. The reason we don't perform a census is usually cost and time. We can't possibly make it happen. Non-sampling error is just mistakes that are made. A nurse might give the wrong patient the wrong drug, might transcribe the number. Instead of a blood pressure of 83, they might put down 38. An instrument that we're using to measure might be defective. Just mistakes that don't have anything to do with the design of the experiment. All right, so now we've had a brief introduction to Chapter 1 on data. I hope this has been helpful, and I wish you luck this week.